All right. So I guess we're jumping in. Welcome. Daniel, do you want to kick it off with some introductions?
Yeah, sure. Hello, everybody, and thanks for joining our session. And hopefully, you are keep enjoying the JDConf virtual event, one of the best one in the world. And then, so Brian and we are talking about empowering Quarkus application with AI, like a plus Gen AI, and then OpenTelemetry on top of the Kubernetes in the next 25 minutes. If we go into the next slide.
Yeah.
So my name is Daniel O. I'm working for Red Hat and then developer advocate and Java champion as well. So yeah, here's my Twitter handler, Daniel030. So you can ask me any kind of question, Java, JavaScript, and Quarkus Spring Boot, of course, and then a bunch of other things, serverless and GitOps and Kubernetes, something like that. Here's my friend, Brian.
Yep. Thank you, Daniel. So Brian Benz, cloud advocate at Microsoft. I've been there about 11 years now, working with Java and working with the cloud. And most recently, working with AI with Java in the cloud. So I've got some cool demos to show you. But yeah, you can find me on Twitter and all the socials, including GitHub at bbenz.
That's cool. And by the way, I'm based in Boston, and then pretty much Brian, West Coast side, right?
Las Vegas. I'm
Yeah,
actually based in Las
nice
Vegas.
city.
I stay here today.
All right. So yeah, the first part, I'm gonna really talk about Quarkus and OpenTelemetry. I mean, for Java developer, you are pretty much interested in observability, like open tracing, open sensors. Now we have OpenTelemetry combined two projects, which is the second largest project in CNCF, right after the Kubernetes. So problem for developer, okay, how to enable OpenTelemetry to Java application using Quarkus? Next slide, please. So this is a common question for developers in terms of observability. So you got to hit this question. For example, what is the health of my application? You got some error, you got some exception, unexpectedly on your production, sometimes in local machine. Whenever you got to hit error, you got to find the root cause. You can go to like a Stack Overflow or Googling, or you can ask a Copilot. We're going to showcase that stuff today. And then more important thing, you got some performance issue, and sometimes that could impact your customer experience as well. So whole kind of stuff. This is a reason why you need to understand and then implement some of stuff, your observability stuff. Next slide, please. And observability is technically combined three pillars, like a metric data, for example, Prometheus. You can have graphing some metric data, not only application, but also like a resources utilization, CPU, memory, or JVM, or some application, hidden memory, etc. And all kind of application logs, like from application side, not only Java, but also any kind of application platforms and frameworks. And tracing data, your application pretty much running on cloud like a Kubernetes and a distributed architecture, which your application literally chain the application architecture. So you can keep tracing your application chain, and then you got some error, and you could literally find out which application you got some error. Like some, that's the reason why you have a circuit breaking or fault tolerance, avoid some cascading some errors. Next slide, please. So there are many observability tools, open source project to enable this kind of capability on your application. But today we're gonna focus on OpenTelemetry, which is the second largest one of already standard, de facto standard on observability area, like a landscape. So in order to use OpenTelemetry, your Java application, you need to specify your implementation using API or SDK. You can also instrument your data and collecting telemetry data like a metrics, logging, tracing, and the sending to or export to external services. It could be Jaeger, could be Jenkins, could be any infrastructure to put together and visualize that telemetry data. So go on next slide, and then here is the Quarkus actually provide extension. You can actually have on your Maven Java project as a dependency or Gradle project using module. So OpenTelemetry extension allows developer get telemetry data and send it back to your tracing infrastructure like a Jaeger server or something like that. So not only trace your RESTful API, but also you can actually trace the JDBC transaction as well and visualize them. And a lot of people are actually asking me, hey, Dan, I got some issue because I already pretty much implement open tracing and then how to use OpenTelemetry. Luckily, we have a migration documentation and example from open tracing to OpenTelemetry tracing on Quarkus. So I'm going to hand it over back to Brian, talk about Azure AKS for deployment and measurement. Go for it, Brian.
Thank you, sir. So yeah, I'm going to talk a little bit about Kubernetes, how our managed Kubernetes and all that stuff works. But first, I'm going to show you the actual app that we built today as a demo. And it's basically, some folks might be familiar with this from 100 years ago. This is Minesweeper. We call it Microsweeper. And it's an interactive game, so you can click on it and play around. And this is running on AKS. Over here on the right, this is actually data that's stored in a Postgres database on Azure. Ooh, okay, so there's that one. And when I save this, it actually saves the results over here on the right in Postgres because it's really important to save that data. But it's a great little demo for keeping just showing people how this works. So behind the scenes, what we've got is let's see here. So we've got a couple of pods. Basically, all we've got is 2 pods that are running. This one is our app service. This one is our collector for open tracing, and they're both running right now. And what I'm going to do something a little bit bold. I'm going to share a link, and that link, everyone can play around with the app. So if you folks want to share the link, if you look at the comments, you should see a link there. There you go. Go ahead and play with the app. We want to get some telemetry data so everyone can go ahead and play with that app for a minute. I'm also going to do something, and I'll explain what I'm doing afterwards, which is, hang on, let's go back to there. I'm going to fire up a load testing run. So let's run this. And this basically runs 300 virtual users against the application itself. Oops. Okay. There it is. Rerun. There we are. And it's going to run 300 users. Let's just type whatever we want in here. And the test URL, blah, 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 rerun. There we go. So that's going to take a minute to spin up. And while that's spinning up, what I could do is explain to you what you've been looking at here. Let's zoom in here. So this is the Azure portal, portal.azure.com. I just fired up an Azure load testing instance. And the Kubernetes cluster that we're using is called Microsweeper Quarkus. That was created using the Azure portal. You can also use the Azure CLI. I've got a database for Postgres, and I've got a container registry. So those are the 4 components that we're actually using to build this. And the repo can be found at github.com bbens microsweeper-quarkus-jdconf. If you go to my GitHub repo at bbens, you'll find it there, and it's also forked from Red Hat, so you can grab that one. And go to the jdconf branch. So you want to go to the jdconf 24 branch. And Daniel has actually provided a really great overview of everything that I did to build this. But I'm going to show you a summary that I've got in VS Code that pretty much does the same thing. Before we do that, let's just check those pods, see if they're scaling up yet. Not yet. Okay. So it takes a minute for that job to spin up. But in the meantime, what I want to show you is what I did to run this application in Maven Quarkus Dev. You run that locally. After that, we're going to create the actual application. So what I did is create a resource group called Microsweeper Quarkus, created an Azure container registry called Microsweeper Quarkus without the dash. You can't have a dash because it's based on Docker Hub, and that's one of their limitations for names. And then create an AKS cluster called Microsweep or Quarkus, then a database, and we create a database called Score inside of there. We set a firewall and password, and then we have to set up a secret. So we actually set up a secret for Postgres. This is what the secret looks like. You just put your username and password in here, and then kubectl apply. You post that to the Kubernetes cluster, and once you've got that set up, you update the Kubernetes properties. So an interesting thing about Quarkus is you don't actually edit the Kubernetes deployment manifest directly. The Kubernetes manifest is actually generated from the application properties file and a couple of other things. So what you do is you customize the application properties file. Specifically, you update the database configurations, you update the container image, and you update the Kubernetes secret that I already mentioned there. So to do that, let's go in here. You can see here the customization for the Quarkus connection to the database. Actually, this is for the for the Postgres database and the database that you're actually using. Then you've got the username and password. This is an old one. This is the username and password that we use. It's passed from that environment variable that we just created with Kubernetes. And then we go into the AKS configuration. We set up the target as a Kubernetes and a type as load balancer. And if we go down here, you specify the image, the container image that you're actually going to deploy to. And you basically, once you're done with that, set up the Postgres credentials and the secrets enabled. And then you do a Maven clean package, and that creates some Docker images. So we can go ahead and look at those Docker images. And in there, we've got one called Microsweep or Quarkus AKS. I already pre-created this in the interest of time. And this is the one you want to use. So you find this Docker image, and then you actually log into your container registry. You push it to the ACR. Well, let's go in and look at that. So if we go back over here, one of these is the container registry. There we go. And in there, if you go into repositories, I've got the repository here. It's already been pushed, and it's just sitting there ready to go. All right. So once that's done, we actually push that out to the repository. Now we can actually deploy this out to the Kubernetes cluster. And to do that, we use the customized generated Kubernetes that was created when you do the Maven clean package with the cluster itself. So for that, there's a key part here. I just grabbed the segment of the Kubernetes deployment manifest. Using the namespace, you choose that repository reference that I just showed you. And then anytime there's an update, it's going to deploy automatically. You use the container port 8080 and the service account name. So you just say kubectl apply and the target /Kubernetes/Kubernetes YAML. That's the one that was actually created by the Maven clean package generation. And you've got the app up and running. So that's basically what we're seeing there. Let's go back and check the pods now. Let's see what we got. It's still not scaling. Okay. It's not scaling anything yet. I don't know why, but anyway. Should be seeing more pods here for the simplest collector. It usually scales a few more pods and a few more nodes as we go, but it's not doing it here. Okay, but that's all right. So that's basically in a nutshell how you actually get the code out to Kubernetes. Then we want to talk about OpenTelemetry. But let's go back over here to the slides for a second. So the way that managed Kubernetes works basically is that everything that you see here in this box, the API server, some data stores, schedulers, controller managers, cloud controllers are actually controlled by something called the managed control plane. So that automatically scales for you in AKS, which is very, very handy. It allows you to not have to worry about all of the management of the cluster itself, the healing, server monitoring, and things like that. And there's some cool monitoring stuff that you can use with OpenTelemetry and some other things as well, which are based on OpenTelemetry, which I'll show you in a little bit. Next up, streamlining the telemetry with GitHub Copilot. I did want to show you a little bit about that. So those of you, some of you might have noticed when I used Copilot there that there's a little thing on the right for Copilot chat. I'm going to show you how that works. So basically, GitHub Copilot is an amazing autocomplete. You can do all kinds of cool things. Just add some documentation and stuff like that. Everyone's familiar with autocomplete, but this is way, way beyond that. And then we have the newer feature, which is our Copilot chat. And that actually goes out to an OpenAI codex, which has scanned a ton of source code out there in the world and pretty much is an expert on any kind of application source code and YAML configurations, which I'm going to show you in a minute. So you ask a question, it understands context as well, and then it gives you back suggestions. And it works on Visual Studio, Visual Studio Code, NeoVim, and JetBrains IDEs, including all of the JetBrains IDEs, basically. And it just recently implemented for JetBrains the Copilot chat. Before that, it was just a standard Copilot. So check that out. If you've checked it out in the past, Copilot chat is now available in all JetBrains IDEs, including IntelliJ IDEA. All right, so for context, it keeps track of file names, any open files, where the cursor is, and anything you've selected in a file. You can also use something called code spaces. So code spaces are a virtual implementation of Visual Studio Code. It runs in a container, but you don't need Visual Studio Code installed. So you can use it on any machine, including your phone. So let me show you a little bit about how this works. And this is a cool part of the demo, I think. So what I've got here is I've got a segment of a OpenTelemetry deployment. It's in OTel collector config YAML in the demos files that we have. And it's just a segment. It actually won't run by itself. So if I try to do kubectl apply file OTel collector config YAML, it's actually not going to run because it doesn't have enough information. So what I can do is I can go here, select it, and I do Control-Shift-I, and I go into Copilot and I say, how do I deploy this to Kubernetes? And this is the kind of fun thing because sometimes Copilot can be a little bit capricious. So basically it's using that reference and it's saying to deploy this OpenTelemetry configuration to Kubernetes, you would typically create a config map containing this configuration, then the config map and the Kubernetes deployment then deploys to OpenTelemetry collector. So that's kind of cool. And here's an example of how you can create the config map. And then down here, it actually gives you the actual collector. So now what I can do is I can say, oh, that's cool. All right. So I didn't need to know how to do that. I don't know if anyone's ever tried to figure this out before. I find it very cool for something like if a file's just not working, you just paste the file in the Copilot chat and say, fix this. And it'll go, oh, yeah, you've got 4 spaces here and this is out of order, and it'll fix it for you. I can insert this into a new file, and I can go down here and I can create this one as well as a new file. So now I can close my Copilot and I've got 2 working YAML files that I can use to actually deploy this. I can deploy the config map and then I can deploy the OTel collector. And just from this segment, we have all the things we need to actually do this kubectl apply file, and it'll actually run. So that's kind of cool. I know I want to just keep things brief. So that's basically the demo I showed you, automated OpenTelemetry integration and deployment on AKS with Copilot. You get the idea. It's something you might be really, really good at OpenTelemetry. You might be good at Java. You might be good at Kubernetes, but all three of those. This is a very rare combination. And so Copilot just says, oh, yeah, I know what to do with this, and does the work for you, which is kind of
Yeah,
cool.
just one thing I want to add, if you don't mind. So
Yeah.
our demo one environment, Brian already installed OpenTelemetry operator on Kubernetes. So
Yeah.
in order
Yeah.
to create the OpenTelemetry CR, you need to make sure install OpenTelemetry using like operator or helm
Yeah.
chart on top of your Kubernetes.
Yes, there you go. So install the OpenTelemetry operator. That's what you do. First, you install a cert manager, and then you install the operator. And then you can deploy a simple config that's been created, and that's in that repo. Kube control apply, and this is the one here. And then I showed the config YAML and how to actually fix that YAML file. How would you deploy it to Kubernetes? So that worked.
Yeah, that's right. And you have to ask a very smart way some of the question to Copilot.
Yeah.
If you're not, and then you got some wrong answer, and then you got to
Yep.
fail to create your OpenTelemetry stuff on your Kubernetes.
Absolutely. Yeah. Prompt engineering. Once again, it's really, people dismiss it as, oh, yeah, you're just talking to the computer. Well, that's what code does too, right? So you really, really need to understand the format that you get the best results from our open AI. Now, and it can be capricious, by the way. Once in a while, it just gives you garbage. So will this stuff replace expertise? No, because sometimes it just generates complete garbage. You need to know enough about OpenTelemetry, AKS, and any kind of Java applications, including Quarkus, to know if what OpenAI is giving you back makes any sense. So.
Yeah, one good thing is for like developers, Java developers, so you can actually save your time during inaudible process with the Quarkus, because the Quarkus automatically generate Kubernetes manifest, and then you can externalize your sensitive information with this Kubernetes secret, which exactly Brian showcased just a bit earlier. So you could spend a little bit more time to figure out OpenTelemetry with the Copilot, and then with some documentation as well.
Yes, absolutely. And okay, so let's go into insights. So this is some of the practical instrumentation and implementations we have. You can see, I decided to refresh it. It's going to take a second. Let me go into some of the metrics while that's refreshing. This is actually an overall metrics page I wanted to show you, and it wasn't updating, so I refreshed it. Now it's taking its time. There we go. All right, so you can see we did the load testing, and look what happened. It started firing up. I'm going to make this a little smaller so you can see all the different things. So we got the node CPU virtual utilization. I guess for the 300 users, for the servers that we have there, it didn't need to add more nodes, so it just ran on the other node. For the folks out there watching, I hope you were able to use it. You shouldn't have noticed any degradation in performance or anything. If there was a degradation in performance, it's set up to auto scale. So, but it looks like our memory and our node count and everything's pretty solid. We also have some other metrics we can show you, like, okay, microsleeper Quarkus, select metric, in-flight requests. So basically, it's just been scaling nicely, and I can add a metric here. I can choose cluster health. There you go. It's pretty solid. I can add a metric for, let's see, nodes usage percentage. Let's add that. Oh, yeah, there you go. So that actually, this is the test I did last night. And this is the test for today. So you can see the percentage went up, but it never went over. Boy, it really didn't go over very high. So the highest we got here is for the CPUs is 2 or 3%. Wow. Okay. So we didn't really need to add any more nodes. So that's why it didn't scale up for us. We've also got some other, I can actually go in and look at the OpenTelemetry data that's being collected from that collector. If I go in here, I can go, let's go back to the main screen. All right, and let's go to controllers, and I can say OpenTelemetry. And I made this a little bit smaller so we can see everything on the screen, but I'll zoom in a second. All right, let's look at the manager. And in here, I can just view this in Log Analytics. And from there, it creates an automatic query for me. And I can run that query. And here we go. So, we got some errors. All right. OpenTelemetry operator, container ID. Anyway, you get the idea. You can actually do a query. You can run data. You can find information here on your OpenTelemetry itself without doing any other kind of visualization. Of course, you can use, as Daniel mentioned, Zipkin and also Jaeger as well. But you can look at the data here too. And you can store all this data and save it as well. And you can share it and do all kinds of things based on the metrics that are built in here. All right, so I think that's basically wrapping up. We got